All right, so I'm gonna show you guys how an eclipse, especially a solar eclipse, proves that Earth is not spinning. Like I told you guys on the last video, both the sun and the moon travel from east to west. That's why you guys see the sun and the moon travel from east to west. Okay. The difference is that the sun travels a little faster than the moon. So when the sun overtakes the moon, that's when the eclipse happens. So as the sun starts getting closer to the moon, the shadow of the eclipse begins in the west, and then as the sun overtakes the moon, it starts moving east. So if I draw a sun here, the shadow would be straight down. As the sun overtakes the moon, the shadow moves east. So the shadow moves the opposite direction depending on the angle of the sun and the moon. Like I said, the sun goes a little faster than the moon. I even wrote some arrows. As the sun starts getting closer to the moon, the shadow starts in the west. And as the sun overtakes the moon, the shadow starts moving east until the shadow moves east, until the sun is too far away that the shadow doesn't hit Earth no more. This is basic information. Okay? The sun and the moon travel from east to west or clockwise. Earth is like a giant clock. The sun and the moon go clockwise, but the sun goes a little faster. I wrote the arrows. The sun and the moon goes from east to west on a flat, stationary Earth. Earth doesn't move. This only works if Earth is stationary. This only works if Earth doesn't move. Now I'm gonna show you guys a video. Let me show you guys his name. The name of the channel is called Flat Out Truth number 2. How the solar eclipse works. This is a great video. Remember how I told you guys that Earth was like a clock? Earth is round like a circle.
Hour hand. The sun will eventually pass over the top of the moon, just like the minute hand will eventually pass over the top of the hour hand, causing what we know as an eclipse, as you can see here.
As you guys can see there, the sun is coming a little faster than the moon. The eclipse happens when the sun overtakes the moon. Just like that. Obviously, the placement of that sun and moon is not correct. This is just an example so you guys can see. So as the sun overtakes the moon, obviously the moon is below the sun. That's why we get a shadow. That's what causes an eclipse, when the sun overtakes the moon.
In just a few hours, the moon will pass completely in front of the sun, that event called totality, casting...
This was the path of the 2017 solar eclipse.
The so-called path of totality spanning 14 states from Oregon to Charleston, South Carolina, where we find world news tonight.
Now I'm going to show you how the eclipse went from the west coast of Oregon to the east coast of South Carolina.
So you guys can do this experiment at home, anywhere that's dark, with a flashlight and a ball or a penny or a quarter, whatever you guys want to use.
Clockwise in a circuit around the flat Earth disk. Okay, now we're going to use the penny once again as our moon, and I'm going to show you how this eclipse took place. Now right here, you can see the west coast of the United States, and you can see the east coast, and you can see the moon over the top of the United States. Now watch what happens as the sun passes over the moon.
You guys see the shadow? That's why obviously the shadow is too big, because the moon is way smaller than that compared to how big Earth is. You guys see how it goes from west to east? Let me rewind it a little bit.
The sun passes over the moon.
You guys gonna see why the shadow goes from west to east as the sun overtakes the moon.
Only on a flat Earth.
This works only on a stationary flat Earth.